Okay, so example number 4. A home alarm system has a 3-digit code that can be used to activate and deactivate the system. If the homeowner forgets the code, how many different codes might they have to try? Digits can be repeated and include 0 through 9. So hopefully you remember from our last example that when you're talking about digits from 0 to 9, that's 10 possible numbers. Okay, next up, 3-digit code. So 3 blanks that I'm trying to fill with these different numbers here. 3-digit code, 10 possible choices. So 10 for the first choice or for the first spot, 10 for the second choice, and 10 for the next one to give us 1,000 different codes. Because again, I'm picking a number and a number and a number, not or. Now, I just want to pause and talk for a second because on your homework, you deal with one where the digits cannot be repeated. So if you had 10 choices, let's say cannot repeat. So if you have 10 choices for the first one, that's still true because there's still 10 digits between 0 and 9. But this time, you picked that digit and it cannot repeat. So now you no longer have 10 possible choices, you have 9. After which, you then have one less possible choice because, again, you cannot repeat that same digit, so that just lowers the possible number of choices. And again, you would just multiply and get what you need. So keep that in mind for your practice problems. All right, finally, part B here. The homeowner suddenly remembers that his 3-digit code has the numbers 4, 7, and 2, but he doesn't remember what order they go in. So how many different codes are possible with those 3 digits? So this one definitely not too bad. You could figure this out by hand and just reordering and reorganizing those 3 different numbers. But if we use our fundamental counting principle that we've been working with, how many possible choices? Right there, we know that there are 3 choices for digits. He just doesn't know what order they go in. So, for the first line, I could either put a 4, a 7, or a 2. So that's 3 potential choices, 4, 7, or 2. Whichever one I pick, I know that I can't repeat it even though they didn't tell me that because I have to use 4, 7, and 2. And if I use 2 4s, that doesn't leave enough spaces for a 7 and a 2. So that narrows my choices down to 2. Last but not least, there's only one potential choice, which 3 times 2 times 1 gives you 6 combinations. 6, well, we'll just go 6 codes. So not too bad, right? You could do 472, 427, 742, 724, 247, 274, and I think that was all of them. So fundamental counting principle